Response to a Piro video, apparently. Apparently it's Piro. Emendum and QM don't understand each other, blah, 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 whatever. So we're still arguing this two-slit stuff, what has been proven or what hasn't been proven. He keeps saying certain things are proven. He keeps saying they're established. I'm saying, no way, not even close to that. There's lots of explanations for what has been observed experimentally. And, yeah, it's still open book, and it really should be a book that the physicists try to close. And the absolute proof of just how stupid the whole thing is like, yeah, if you take a bunch of these, highly degreed physicists, put them in the room, they won't agree on this fundamental truth of what interpretation is the valid interpretation. They can't figure out how many dimensions there are in the universe. That's pretty fucking pitiful. And I guess if what they're basing it on are these experiments, then maybe they ought to do these experiments a little bit better. Maybe they ought to do that. Maybe that's not asking too much, Piro. Yeah. Anyway, so I have not watched his video, and I will just play it through just as he is doing to mine, and we'll see if that goes anywhere. And so there will be in pieces of video, because I will ignore the part where I'm talking and just deal with the parts where he's talking substantially. And so there.
They keep confirming that you want them to spend whatever money it takes to deny that. Well, let's get a little frame of reference. Einstein didn't approve of some of the aspects, the implications of quantum mechanics, but he respected it, and he knew that the only way to overcome it was to come up with a system that...
Look, I don't think Einstein had any grievance with quantum mechanics. I think he had a problem with the interpretation. So again, we're back... No one's arguing quantum mechanics here. We're arguing the interpretation of the two-slit experiment and whether the fact that we have, through quantum mechanics, constructed math that enables us to take the idea that we don't have explicit information regarding the exact state of a particle, the fact that we don't have that information, and we have used mathematics to envelop that truth in a probability curve that's based on time. So it adds in this element of what happens over time into the math. So you can take static math about one individual item, apply math that essentially allows it to be run through time and to have a probability component, and then redo the math back in a stable moment. Look, that's sort of what quantum mechanics is doing. I've called it error math before and probability math. I've called it lots of things, but that's the element, that's the essence of quantum mechanics. It's not some magical math. It's not dimensional math. It's not any of that crap. It's just math that allows you to take an uncertainty and move it through the equation without destroying your capacity to do the rest of the math. I mean, it creates a constant out of a variable for the necessity of constructing a conclusion that would be consistent over permutations. Damn, see, as soon as you start saying this, the explanation gets a little bit convoluted, gets a little complicated. But that's the truth of it. It allows you to take a single equation, run it through more than one rendition, and average out a result, and then apply it to an individual circumstance, which doesn't sound like it should be possible, but it does allow that. Well, anyway, I don't want to get into an argument about quantum mechanics. This is not about quantum mechanics, the math. This is about theoretical physics. The bullshit.
Good model reality as well as it does, and in some way better, right?
In some way better, as well as it does, and in some way better. But yeah, it models reality better than reality does. I mean, you have to be a little more careful than that kind of a bullshit.
He failed at that. He spent the last 20, 30 years of his life doing that. Failed. It's not going to be easy.
Well, I say bullshit. I say that the not easy part is just getting back to a zero state where you take all the lies and the fantasies out of this crap, use some real science, and just start over again. Redo the two-slit experiments in more controlled environments where you can control exactly the phenomenon. Because I'm arguing that I can analyze the experiment, I can show you where it goes wrong. In every single case that it's performed, I can show you where it goes wrong. where they cheat?
First off, I mean, this whole quantum mechanics thing, again, it's the math is not creating, is not indicating, it's not proving the existence of random or
well, I think that your understanding of random is wrong. I mean, random in classical mechanics means something different than it means in quantum mechanics, and one of the most
Yeah, so there. Foul, flag on the play. This crap where everybody's going to change the meaning of words, right? Let's use the same word, but give it a different meaning. I mean, if you're a scientist and you're too fucktarded to come up with a new word for a new concept, then you know what? You should be kicked in the ass. You should be humiliated and insulted. I mean, this is where it all goes bad. The whole idea that you stole the word wave and they applied it to start applying the same word to concepts that had nothing to do with the common understanding of what a wave was. It's in a medium. And they've done this with vectors. They've done this with, what's the other one that's a big, huge one where they sit there and applying the same, it's just stupid to use the same word. So this idea that you're going to have a contrived random, I'm sorry, it's not random then. Well, whatever, go ahead. It's just stupid to sit there and say, oh, it's not real random, it's this new random. The new random. Yeah, the new everything. The new fucking lie. The new God.
Significant ways I can think of that that's the case is that if you have a random energy fluctuation in a classical system, the system won't have conservation of energy. It'll wander. It'll drift. If every once in a while you're just allowed 1/1000th of 1% of randomness in energy.
Well, he's just making this shit up. There's no such thing as randomness. So this is just bullshit, right? You're already in huge trouble.
It appears, boom, at this location. It would not have conservation of energy. Yet that's what the kind of thing that goes on with quantum mechanics, and yet there is conservation of it.
Yeah, well, that's because obviously quantum mechanics cheats, okay? It's obviously. It's not one event, okay? Again, the randomness is a contrivance of accepting the fact that you're basically doing math for a whole bunch of events and applying, you're modeling for a multiple of events and applying it to a single event. And that's what quantum mechanics, the math, allows you to do. But that isn't in reality. You don't get to do that in reality.
Energy. If you have that random amount of energy here, somewhere else you'll have a random amount down, and the thing stays in, as far as we could tell, perfect conservation of energy state. So somehow those things are connected, but see, that's the part Einstein didn't like. How would those two particles behaving randomly know about each other? They must be related, is the answer.
Yeah, no. I saw the Borg Einstein conversations. I saw some of that debate, the conversations they were having, and they didn't take the two-slit experiment seriously. They didn't take these interpretations seriously. They really didn't. Okay, Einstein was basically saying saying something similar to the effect that I'm saying. He was saying, well, what is it, bouncing off of something, blah, blah, blah. I mean, I think Einstein, I don't know why he let this go for so long without saying, why don't we do this thing and get it fixed? Because it really is a mess. All right, what are those two outside walls doing? What is their function if you're going to sit there and say particles go split in half and go through two slits? What are those outside walls doing?
One particle, and that's what quantum entanglement is that particles can share an identity that seems to unify them even when separated by great distances.
Yeah, well, whatever. This whole, beyond the speed of light communication between particles across the whole universe, I say bogus to this whole nonsense. So, no, sorry, no sale. No proof either. Nothing that should be qualified as proof. Long way from there. Alright, geez, 9 minutes already. Fuck, 10 minutes. Alright, well, let's see how it goes. I'll try to speed this up.
Saying this. These are people like Niels Bohr, okay? And on. People that have thought this through really well. Even Einstein, who didn't like the implications of quantum mechanics, happens to be somebody that helped start it.
There's no implications of quantum mechanics. Again, another lie. All right, you're just going to keep lying about where quantum mechanics came from and what the conclusion is based on. The difference is in the whatever Heisenberg bullshit. Okay, whether you believe that these particles actually don't have a location and a direction, or you believe we can't know it with the instrumentality we have. Those are two different interpretations, Pierrot. All right, right there from the start. Two different interpretations. Okay, Einstein's interpretation was, no, we can't do it. We don't have the instrumentality to know where it is. Okay, that's different than saying it is unknowable. That's different than saying the particle itself is actually creating some sort of improbability. Saying you don't know where something is and you're guesstimating that it's somewhere on the island. I could dump somebody on an island. I could wait for a day and I could say, well, where is the person on the island? I wouldn't know exactly where the person is, right? So I could do some math to figure out probabilities of where the person is on the island. Or I could, and both people could do that. One person could do it based on the premise that the person is anywhere on the island, that he could be anywhere, that he just bounces all over the place. He comes in and out of reality. He jumps dimensions and he pops in and out all over the place. Somebody could believe that crap, and somebody could just honestly believe that, no, the thing has a position. It's somewhere on the island in this very second, this very moment. It's in a position. And it is calculable. We just can't calculate it from 500 miles away. We don't have any instrumentality to tell us exactly where the person is on the island. But we both can use the same math of island math. We can both confine the person to being on an island. All right? So don't tell me that Einstein doesn't like. No, that's not what Einstein didn't like. Einstein didn't like this bullshit where you people start inventing 15 dimensions and all kinds of other bullshit to explain what's going on. Because it's that. It's fucking bullshit. God, you really are annoying.
Except
on this subject, especially.
The fact that
all right, we'll move
when
on.
we can't detect
of that is to shake out if it's just a matter. Is the uncertainty principle just that a theoretical thing of you're going to have to touch something? No, it's different than that. If you put constraints on the momentum, you really have released constraints on the position. Okay, and it actually has possible positions throughout a greater area. And those possibilities can be seen to exist because multiple of them can overlap and you can see the pattern of their overlap.
There'd be no way I couldn't interfere with.
All right, so in this part, again, so he's brought up the Heisenberg thing. But again, he's saying the two-slit experiment is proving something, once again. So he's drawing the conclusion, okay, and it's just that. Without seeing it, without having any way to detect it, right, that, a photon or electron is going through both slits at once, interfering with itself and creating the pattern. And that's what's actually happening. And I'm going to argue that there are other mechanical processes that can be described that will account for the behavior of the particle. And some of the physics points to the fact that if you go backwards from the target, you can always find a way to go through one of the slits or one of the other slits and get back to the source mathematically consistent. So there's no need for this two-slit experiment to get back, to go the other way. So, again, the argument is that there are ways to do this experiment, in my opinion, ways to do it that can eliminate what might be these possibilities that have to do with the nuances of the atomic structure of subatomic particles and the fact that they don't interact with anything firm. Again, people have to remember that when you have two slits, the slits are not made out of this. They're not some flat, hard thing to a photon or an electron. That's not what a photon or an electron sees when it goes by a substance or through a slit. What a photon or electron sees is other electrons. It sees atoms. It's interacting with the particles going around a nucleus. It's not interacting with a surface, a flat-edged surface, and it's just going to sit there and do nothing. No, it's going to be interacting with atomic structure, okay, with other electrons. And for photons, in my opinion, electrons are made out of photons, so yeah, it's going to be reacting with other clumps of photons. And that's where this phenomenon is coming from, is the interaction with the matter of the slits. And again, I would ask somebody to explain the role of the outside walls to the slit. Because you can't possibly be arguing that the wave of if all atomic particles had waves radiating from them, okay, big enough to go through both slits, and to need the outside walls to create the friction to create a second wave, so they actually did create two waves, you'd have to explain the energy loss from the middle impediment. You'd have to explain how these waves could possibly go, that all the wave energy would go through the slits and none of the wave energy would be absorbed by any of the slit material. So you'd sort of be in trouble on that score even. But let's not even get into that detail of an argument. I think I'm talking again. So.
My math is...
Alright, so this is why he's talking a little bit about superconductance, which is different. But anyway, let me finish it.
Treat these things as waves. They're really short wavelengths, so it's not easy. But knowing that they're waves means you can't treat them that way. Doesn't matter if it's also possible to treat them as particles. Great. You can do that too. That's what we started being able to do. So
yeah, so you're contradicting yourself anyway, all right? And the thing with the superconductor thing, it's not about quantum. Again, quit talking about quantum mechanics. Quantum mechanics is not the argument. The math of quantum mechanics is not the argument. The argument is the interpretation, and what you are arguing is the source of the probability wave that you're using in quantum mechanics as a variable fill-in for an explicit number. It's explicit over time, but it's not explicit in one instance. And quantum mechanics allows you to do the time permutations. So I'm not arguing with the math, I'm arguing with the interpretation of the source of the irregular variable that quantum mechanics attempts to make regular, or does explicitly by time coding the math, essentially, or whatever you want to put this. So again, nothing in classical physics said superconductance wasn't possible. They just didn't speculate on the capacity to make materials that would be suitable for superconductance. Okay, you can only have superconductance when you change the nature of the material that becomes a superconductor. So that doesn't break classical physics, only in the sense that classical physics couldn't imagine materials that we now can create in terms of making something that's still a conductor but has none of the real properties of a conductor.
the more advanced thing was finding out, oh, they're waves. And then the games you can play with these things, it's like the idea that any solid thing, in a sense, can be put in certain situations where it could be liquid, you know, where it can be energy, right? Where it could teleport. Now, I can't teleport if it's something like this, but if it's something like a photon that's likely to be absorbed, it could basically be teleported to the place that it needs. So that instead of being absorbed 98% of the time by the little chemical pathways that it has to bounce along to get to the energy storing center in the leaf, in the plant, instead of doing that,
well, you're not going to teleport it. And anyway, teleportation would be more about reconstruction. It'd be more about just modeling and then creating another copy. So it's Xeroxing. It's not teleporting. But whatever.
It soars along 98% of the time, getting to the end. Because a waveguide is designed just for its wavelength, taking into account just it's tuned, rather, to its exact properties.
Really cold.
Well, again, this isn't part of the argument. Okay, all of these physical phenomenon, I'm saying, can have different interpretations. All you have to do is change the way you model them. Okay, so this wave model has no explicit model. It has no visual model, so far as I've seen. Okay, and so until you create one of those, you're not going to have much to work with in terms of creating something that can be seen. But I mean, three-dimensional models get difficult anyway. I mean, even Einstein's curved space is a little bit dicey in terms of trying to visualize it in 3 dimensions. But regardless, what I'm saying is there quite possibly, and I'm saying there probably will be, an explanation where regular particle physics will work. That the wave phenomenon is really just a phenomenon of the structure of the thing. The thing has a structure. Okay, not all photons are alike. Maybe photons have 10 flavors. Maybe photons have 100 flavors, or energy levels. And when there are different energy levels, they behave differently when they go through a slit. So even all light of the same wavelength may have 100 variations built into that wavelength, 100 positions that it will be in when it reaches a slit. And in any one of those positions, it will dictate a certain behavior that creates a pattern, because those are the only 100 possibilities, and those 100 get reduced to 10, or maybe those 100 get reduced to 5. But it's that the math of that can be just as, I'm just saying there are alternative explanations that are just as consistent with the facts you've observed. The facts you've observed are limited facts, not abundant facts. Irritating. Okay, this is the part where I say the one divider experiment. Let's see what Pirot says to that.
We're talking about.
I'm sick of people getting hung up on this, you and others as well. It doesn't matter. Any experiment you do will show the wave-like nature.
Well, I'm sorry, not every experiment you do will do that. Most experiments show exactly the opposite. Most photographic film shows exactly the opposite. Where's the wave-like nature in photographic film? There's no evidence of a wave-like nature. There's evidence of particles hitting the film. Our eyes. All these other experiments, there's no wave-like nature bullshit. No, there's pretty much the idea of a particle, a pixel, flies in and just hit pixel, 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 pixel. There's no wave-like nature crap.
Two-slit experiment is useful because the width of the slits, you can tune that to the wavelength of the particle, and you can basically amplify the effects.
Yeah, right. Wavelength of the particle gets a little tricky because those slits aren't anywhere close to that small. But anyway, that's just defends my point here, is that you can do that with lensing too. The smaller the hole, the more accurate the lensing effect becomes. And so it's all about that outer perimeter of a hole. So the one hole, the single hole camera, the pinhole camera, becomes, it's not demonstrating a quantum effect, it's demonstrating pretty obviously that yes, light can be bent by interfering with a structure that has atomic weight. Anything with atomic weight and static components are going to end up bending light. Photons are photons are easy to bend. That's what the experiments demonstrate. It doesn't experiment anything about a wave. There's no necessity to have a wave-like function to simply say when you make the hole small enough, the truth of the matter is then there's no dead space in the center anymore. Each photon that goes through will be interfered with by the structure of the hole. So that if the hole is small enough, no photon can go through it without being bent some. And so therefore you will automatically create the image, the upside down and inverted image, because every single photon is inevitably going to be bent in its direction by the circumference of the circle. And so then if you go smaller than the wavelength of the light, that would be the curious experiment, because then you'd be creating double images. And maybe that's what the two-slit experiment is doing. Maybe it's just creating redundant double images of its own slits.
They're always there. One slit, no slits, electron going through free space, you name it, it's there.
Oh, whatever, you name it, it's there. What is that? What the fuck is that shit? Let's do the photon through nothing experiment and we can prove there's a wave. Sorry, we have to actually have the photon impact something. Newsflash, we can't see photons. We can't see their wave. They're not even... I mean, you're talking like it's some kind of... Well, yeah, you just have to look at the sky, and there's a meteor coming, and you can, or one of those comets, and you can see its tail. There's none of that here. I mean, come on, get real. Oh, I should finish this comment. Yeah.
On both sides of the divide.
All right, wait, finished. Sorry, my bad.
Okay, fine, but what you just said is the most lucid description of what I'm claiming about this experiment that you've ever said. Exactly. But I'm not saying they're commingled, so in the like the entangled sense. It's just, I mean, my misery and me put up a picture of it. It's if you have a water wave going through a barrier, you know, and it hits the barrier and then it makes ripples there, you can see the patterns of the ripples. It implies there was something on both sides, since you can mathematically say, here's exactly what it should look like. And the fact that when you do this event by event, you get one dot at a time, but over the whole time, you see the pattern. That's where the idea that it's probability. See, the patterns come...
Yeah, whatever. Again, so I just described the two-slit experiment, the idea that it goes through both slits as some kind of broken down energy, that it somehow interferes with itself as if it went through two slits, and that somehow it decides at the end to hit a target. And he said that's the best experiment. Well, whatever. I mean, but it's complete nonsense. It's completely made-up bullshit. It's a made-up model explaining a circumstance. Again, the property of interference, the ability to interfere, the fact that interference takes place regularly, that it follows a mathematical formula in waves, okay, that go through two slits, does not mean that every time that phenomenon shows up, every time bars show up, it means that exactly the same phenomenon created them. It just means that there's the nature of the math creates that capacity. So it all has to do with the density of the material they're traveling through, or instead of changing the density of the material, we just change the structure of the atomic particle going through the slit. So again, we can find these mathematical relationships that can exist inside the thing itself. So we could just say that anything traveling at the speed of light, all right, no, that's the wrong way to put it. Anything with subatomic particles regular to, all right, no. What we do know is electrons have a state, okay? They can be, what's the word for their up-down stuff? All right, they can have a charge. And so all you need to do to establish the possibility of this is to acknowledge that the charge could be in increments, levels, solid levels, like 15 levels or 12 levels or 8 levels or 7 levels. And that only when they got a boost to a certain level do they acquire that level, like almost the old gas meters where wheels decided what number, how much gas you were using. So as the wheel turned, you'd have to go to wheel number 2 to figure out what the decimal point was. So you weren't reading numbers, you were reading how far a wheel had been pushed, how much potential was built up in a system. And so if an electron is at 7.5 and it receives 3.5, it will release a photon because it's received enough energy to finish it to 10. And then it goes back to neutral again and starts over going around the wheel. So it only releases a photon when it hits 10. So it can be a small amount of energy it needs to hit 10, or it could be the entire 10 amount of energy that needs to hit 10. But the point is that it has potential built into it. And the same can be true of every single photon flying at that slit. It can have a potential. And because it contains a potential, because it has a qualitative state, it will change where it will deflect. And it's that change, and it's that regularity of the change, like I said, if it's all or nothing, that will decide, that can create bars instead of a blanket of even distribution. That's what creates the interference-like pattern, which is only a pattern reflecting the fact that there is a qualitative mathematical permutation built into the structure. Shit. Well, that's good enough for now.
I mean, it's probability, And you only see the pattern when you've expressed the probability, which you need to do with the statistical sample. So give it 1 million dots, you start to see that pattern. The pattern is not there when the one dot fires.
Right, because the one dot, okay, has potential built into itself. So it might be a 7 electron, or it might be a 4 electron, or it might be a 2 electron. And depending on what potential it always brought to the game, and where in this slit it went through, is going to decide how much deflection there is. So there's a math to not only its state, but the state of the material and how close it is to it is going to decide where it's going to end up.
Right? Because it's just one dot. Oh, but that...
Well, again, the thing, look, we know there's regularity built into this, so we know there's a system that's got to be regular built into it. The pinhole camera proves that, okay? Because you're talking about the same phenomenon, cut to the chase, the same phenomenon in a way. I mean, it has to be. It's photons interacting with material, okay, and then and deflecting trajectory, the same elements. And yet it renders an accurate picture, not an inaccurate picture. That's the focus.
That's proof that the pattern existed somewhere, that it expresses itself. And it's only mathematically, really, that it relates to probability, but it doesn't relate 1-to-1. Because that's the kind of pattern.
It doesn't relate 1-to-1 because it's obviously, as you just pointed out, probability math taken over time, taken over many permutations, thousands of permutations.
Pattern that does that. See, if I roll a dice once, I could get a 12 just as easy as a 2 on dice 1 and a 5 on dice 2. But see, I could also get a 5 and a 2 the other way, whereas I need a particular pair for the 12, but any of those rolls is equally likely on the one roll.
Well, that will do nothing to create this pattern on the outside wall. So again, whether this is interference pattern is being created by a single electron going through 2 slits and interfering with itself as a wave, or whether this is a single photon or electron interfering in regular ways with the atomic structure of the slit material and being refracted and diffracted consistently based on the old school mechanics.
Keep rolling over and over and over. Well, I'm going to be misunderstood in that.
Well, the problem is that we can't prove this either way until we do experiments that eliminate for the thing we don't know. Okay, we don't know the source. Okay, so we don't know the source trajectory and position of the photon. So the source is always irregular, and as long as you keep having an irregular source, there's no way to prove this mathematically that it could just be the interaction, because you can't prove the interaction, because you can't prove where the particle went next to the slit or not next to the slit. And I would argue that the fact that when you try to turn some detector on, you break down this wave phenomenon is pretty much demonstrating that you've destroyed one key aspect of what carries the information. What carries the information is where the thing goes through the slit. Where it goes through decides where it ends up. Something like that.
Obviously, there's a bigger chance of rolling a 7. But when I roll the dice, if I roll 2 or 3 times, I'm not going to see that statistical character. It's only over a long time am I going to see it. So what is probability? Well, it could just be this mathematical construct that it is in classical physics. Right.
Or it could be, again, that it's something going into the thing in the first place. Like I said, I could hold up a needle in a laser beam, and the fact is that it could be creating bars, okay, repeats of refraction in the same kind of bar pattern being created. And the only way I'll be able to see it, though, is I can't have the light too bright. If the light's too bright, it washes out that effect. So if there's too much other light, the light reflecting off the surface will wash out my capacity to see what's actually happening. So again, we're talking, this is a subtle effect that is nuanced on just the stuff that's going very close to this material. So the stuff going very close to the material is reacting in a certain way, and the stuff a little bit further out is reacting in a way, and the stuff a little further out is reacting in a way. Each one is reacting differently and more intensely, and the only way you can see one is to try to filter out some of the other. But it's like you can ruin well, let's go through this.
Not real, just a statement of a pattern. And that's what we had come to expect in physics. But the fact that this probability can be made to ripple, you could put a third slit, you can change the angle of the slits. Everything that happens to that ripple is predicted by the wave mathematics of it. Okay? If I threw dice through a slit, I wouldn't expect it to change the probability pattern on the other side.
Well, that just makes it all the more clear. The more slits you add, obviously the more irregular your gun has got to fire to be able to hit those outside slits. So again, we're doing this slit experiment with completely bizarre sources that are firing very erratic particles. So again, I'd say that's almost reason to say, why bother? Why not just shoot a straight particle? Why not put the particle, take a mile tube, all right, have a source at one end, have a hole at the other end. You're going to be pretty darn sure, based on speed dynamics, if you're getting the right particles. You can just filter them out, force them all to go right through a bunch of center holes, and you're going to have a pretty straight gun. You're going to have particles that are moving pretty straight. And then shoot those through your slits and you see what happens. I think you know what's going to happen. They're not going to go through both slits. Yeah, I think you know that.
But with these electrons, I do. I get dark spots and things that are dependent on the fact that there are two slits there, right? So that means that the fundamental particles aren't working like flipped coins and dice.
Well, they certainly aren't, because know what you're not doing? Because you're using these scatter gun, you're not doing these in all the time, the set time scale. So again, you're acquiring this pattern over time. You're not acquiring as a continuity between timing of experiments. So yeah, you might be able to figure out that these are reflected particles just by, if you could do an accurate. If you knew the variable of time, at least that variable would help you isolate the phenomenon from something that was a phenomenon of the scatter.
All right. They're not just designed to select numbers one at a time in what is going to become a statistical distribution. Right? They're macroscopic. They're non-quantum. But at the quantum level, there has to be some reality to this probability, the argument goes, or else it couldn't overlap in space. See, we caught probability in space. Okay.
Yeah, sorry.
Yeah,
no. All right, so now we're at the part where I said something about, when you're doing this one particle at a time, and somehow the particles know where the other particles landed, and this is not a good thing, and this is not going to be explained by quantum theory. This has to be explained by some of the phenomena, but let's see, Prado.
The first particle, he resolved himself left. The far left, like this. Say there's...
Yeah, this is the thing that Einstein didn't like, and I agree. This is why quantum physicists don't like this, per se, and this is why you have this folding of space and somehow trying to look at those things as all in some space, in some Hilbert space, some sort of space, they're co-located so that's how come they can interact over a distance. And this is why we have a big debate on locality and spatial, the spatial side of what does it mean to be local. Because locality is the idea that if I'm going to pick this up, I have to be here with it in its local space.
Yeah, well, whatever. We don't need to do all this stuff. The point is that you just these are theories, they're just made up, okay? These are explanations that are just made up. Now you're going to invent some kind of folded space to sit there and account for something where it could be accounted for if you just go with the fact that we don't know everything there is to know about the interaction between photons and slit material, and that photons could have a character built into themselves that create this capacity to create a mathematically consistent end result that isn't analog but is in fact digitally regular. That is, again, one of these all-or-nothing things. If it's an irregularly shaped thing, if I make an oblong piece of rice and I spin it and throw a spinning piece of rice through space, the truth is, if I have a tiny impediment that piece of rice is going to hit in that spinning motion, it will regularly go left or right depending on how it hits that impediment, right? No. Every time it hits the impediment, it will grab the impediment and spin around it. So it's going to go on to one side much more than it will go on to the other side because of its own spinning dynamic. So just adding a spin to a grain of rice changes what the probability of it ending up on a left side or a right side are. And where it will end up will be decided by how fast it is spinning. So the faster it's spinning, the more likely I am to have one fly all the way out there or one all the way out there. So that, this is all you need to do is add a dynamic to the photon and electron itself, give it properties, and its properties could be reflecting on that back screen. That's my argument. I think it was Einstein's argument too.
And quantum mechanics screws with that idea a little bit. It's something we have to understand. You can't just go, well, that's nonsense, so I don't believe it, because it's demonstrated.
Well, that's your claim. Your claim is that it's all demonstrated. Your claim that it's all proven. No, this theoretical crap hasn't been proven at all. There are lots of theoretical explanations. And my contention remains that if this is kind of important, and they maybe should start spending some real money on doing this in some way that could really illustrate what's going on and break down some of this ambiguity.
And again, remember, it's demonstrated in...
YouTube. Come on, YouTube. Come on, YouTube. I didn't pause that long. You can play the video. Come on, 16 minutes, 32 seconds. Damn, wasting my goddamn time. I went back to 16:12.
Idea that if I'm going to pick a little bit, it's something we have to understand. You can't just go, well, that's nonsense, so I don't believe it, because it's demonstrated. And again, remember, it's demonstrated, and Einstein wanted to get rid of it and couldn't think of a way to explain what's been demonstrated.
Well, I'm sorry. I mean, couldn't think of a way to explain what has been demonstrated. No, he couldn't make anything out of the limited amount of information. We still have a limited amount of information. You're talking like the two-slit experiment is some kind of beautifully illustrative thing. No, when people make jokes about it, they basically say, well, here's the stuff on A side going in, and then here's the end result, C side coming out. Where's B, right? It's one of these missing B things. What happens when B happens? So again, don't be bullshitting like you know what the fuck's going on, because you don't. You have no idea what's taking place when those photons are interacting with that slit material. And you're just making it all goddamn up, and you're saying, there, we proved it. No, you didn't prove crap yet. You're a long way from a proof. Jeez. I mean, that's what's obnoxious about you. You just keep claiming that there's proof, and there ain't proof. This ain't close to what's called proof. Whoops, missed a little bit. Anyway, so he's talking about some old theory I had about the movement of the particles, and where they left a trail behind, or there was some other mechanism like string theory or something else where there's something left behind, and it's the tangling of the strings that decide how they end up in the end result. And then he's using this stupid, like, well, do the dice tell the dice what to come up, or is it written on the dice? Or, I mean, that's not the point. The point is you're claiming that some unknown variable, some unknown circumstance about the unknowability about a circumstance that exists with an electron, like we can't tell exactly where it is, that it's moving around in space, that moving around in space somehow allows it to go to when it goes through a slit to somehow have a wave property that it doesn't seem to have when it's not going through a slit. So it seems to only have this wave property when it's actually going through a slit. Is there some other circumstance where it gains this wave property and then this capacity to consolidate its wave back to an impact? So exactly, the wave would have to be some kind of non-energetic, non-material, non-real part of itself, having nothing to do with its actual mass. No, whatever, it doesn't matter. I still don't think it's the explanation. I think the explanation is something else. It's built into the structure.
More often than the other, and it will actually be random because there's randomness in the universe.
Well, see, again, you said there's randomness in the universe. I don't think I don't think there's a solitary piece of evidence for any randomness in the universe. You don't think you can prove it? I don't think you can say it like that. I think it's just absolute crap. Where? Prove it. Demonstrate one bit of randomness.
It's suppressed by macroscopic systems.
Says you. I mean, you just made that shit up. You don't, I mean, really. I mean, it's just bold talk for somebody with a bad magnifying glass.
Yeah, preposterous. Okay, so what I'm going to...
Forever to render, so by the time that was over, halfway through, didn't have time to finish, and blah, blah, blah. So I don't even remember what I was saying, but I guess I'll finish this. I think I was somewhere around here.
Why the outside walls in the two-slit experiment are
Well, that's kind of a bummer. I mean, so I was just getting to the lensing effect. So I did the whole spiel about the lensing thing and about the fact that, here I'm creating a lens with my finger, and theoretically some portion of these particles are upside down and reversed inside of this camera because of the way I'm doing this. But you can't see it because they're getting washed out because of how much light is in that center part. But if I made it really, really, really small, and it was the only light coming through, you would actually see me upside down inside that camera.
Necessary to creating the substance of the correct interference pattern.
All right, well, I don't know. He's changed the format here in the middle because he had some sort of technical difficulty, so we'll have to come back and I'll check the volume, and I'll wait till he starts talking and blah, blah, blah. All right, so he should be doing I'm doing the outside walls to the two-slit experiment. Let's see what he says to that.
What you need for the interference pattern is two waves. The two slits are able to basically create two waves out of one by masking some of the wave off. And because it still starts to fan out, it'll start to have curvature, you have the overlap.
All right, now, so this is where they're comparing atomic waves, subatomic particle waves, to waves in water, which are two entirely different mediums, right? Theoretically, space is not thick water. Thick water does what's called resistance on surfaces. So when you do the two-slit experiment in water, the tension the water creates the wave front. So you're able to take one wave, break it into two waves, new waves. All right, you generate two new waves because you create two new wave fronts. The energy goes in and it sticks to the two sides of whatever opening you have for the wave. So here's an opening for the wave. The wave, as it pushes through, there's friction on the surfaces, and that creates the new clean wave. If you didn't do that, your interference pattern may not exist. I have to think this one through. It would give them the ability to create two irregular size waves and to see what that does. I mean, that's part of this whole catch of this thing, right, is that the two slits are the same exact size, because if one slit is 1/2 the diameter of the other slit, the wave would have twice the frequency, which would really mess up the interference pattern.
Interference is two things interfering with each other.
Pretty much.
Yeah, I know, but the fact that it looks, again, we're back to it looks like an interference pattern. That doesn't mean it is an interference pattern. There's lots of scenarios where light breaks down into bars of light, okay? Prisms do it all the time. Lots of things create that bar pattern. So to argue that every time you see bars that all of a sudden you have an interference pattern is kind of bullshit.
Defines what's taking place. And this can
And by the way, people have done this kind of thing. People have shot electron beams at everything, And in every case, quantum mechanics makes the correct prediction.
Well, in every case, quantum mechanics makes the correct prediction. This is the bullshit of your arguing with you. These are experiments, and the experiments say this is what the results have a certain result. Here's the beam I shot, this is the character of the beam, this is how much dirt it has in it, how many wavelengths of light are in it. It's shot at an impediment made of a certain substance of a certain size, and a certain thing happens at a certain focal length. These are all important constituents of an experiment. It doesn't have anything to do with quantum mechanics at this point. And to say quantum mechanics predicts it is like saying, yes, when you sit there and fill in the blanks of the circumstance, of course the math that's judging this experiment over doing it 500 times comes out predicting what it does. Of course it can. Why shouldn't it if these are all known quantities? Duh. But it's not explaining how it's done. It's not explaining why it happens. That's your bullshit. Again, how can you possibly say it predicts when you have not isolated the source?
That's how things are going to turn out.
There's already a known effect. Okay, it happens all the time in astronomical observations.
Alright, I'll come back to this. More lensing stuff. Well, this part is typically puro annoying. Okay, so I'm making this explanation about how light functions, how some of it's reflected, it's refracted, it's deflected, it's refracted. Who cares? But yet it does all kinds of interesting things, and instead of commenting on that, this is what Piro wastes our time with.
So a green light goes in, and a red light can come out. A red photon. So it isn't strictly reflecting like a...
I think I might have taught Gary this.
Yeah, I think maybe in your dreams. I have learned nothing from Piro. Nothing. He's been nothing but like a tick boring into my skin. Ugh. Whatever.
A ball bouncing on the ground. The ball isn't absorbed.
But that doesn't happen when with reflected light, you know.
Well, says you it doesn't happen with reflected light. That's the whole problem with this whole conversation, is it does in some circumstances. I think in some circumstances that's exactly what's happening with reflected light. That the original photon goes in and a new photon flies out. And the fact that it comes out angularly and appropriately all has to do with atomic structure. So it all depends on whatever surface it's flying into. But I think some reflected light is not bouncing off an electron. It's being consumed by an electron, and the electron is shooting out another photon.
Right. At the ground, and the ground pops a new ball up. But in physics, that is sometimes what's taking place. Is the one ball goes in, a different ball comes out. And in the two-slit experiment, what's happening is that the material that the light is passing by is distorting, it's interfering with.
The point is it's interfering with it like if it would interfere with a wave instead of the way it would interfere with a particle, with a
No, that isn't the point at all. No, the point is it's digitally, it's going through one slit or the other slit, Piro. It's not going through both as a wave. It's going through one or the other. It's ending up on the target, and the target in a mathematically consistent manner based on how close it is to a slit wall. It's all about the slit walls. That's why the walls have to be a certain distance apart. It's because that's the factor. There is no middle to the slits. There is only gravitationally significant space, or magnetically significant, or electrostatically significant space. So it can't go through any part of the slit without being affected either by the right side of the slit or the left side of the slit. So there's no way it can't be manipulated. There's no going straight through the slit. There's no possibility of any photon going through the slit straight. And that's why every single photon that goes through either one of the slits is getting diffracted by a certain percentage, a certain amount, based on the size of the wavelength of the light and the density of the slit material and the space of the slit material and the distance of the slit material from the target. Damn it.
EV with a bowling ball, with a billiard ball. right? If you have a whole...
Well, we'll go ahead and do the two-slit experiment. Why doesn't somebody spend that money? Yeah, do the two-slit experiment with bowling balls or cue balls or some other kind of ball, and guess what? It ain't gonna fucking work. Right? That's the truth of it, right? You know you're going to be hitting the slits all over the place. You're going to be breaking the balls into a million little pieces, and fragments of ball are going to be hitting your target. Truth, buddy.
Hole and a screen, and you shoot a bunch of things at the screen so they hit all over the wall, and some of them go through the hole. The thing is, BBs flying through that are going to react differently and make a different pattern than a wave going through, which is especially obvious if you make two slits, because waves will interfere and particles won't.
Yeah, and billiard balls are not going to be the electrostatic atomic force. The atomic force is obviously on a billiard ball going past a piece of steel is a lot different than a fucking photon going next to an electron. And that's the reality of the two-slit experiment. It is not a billiard ball and a steel house running next to each other. You're not rolling a bowling ball next to a fucking warehouse. No, you're rolling a photon next to an electron. There is no anything else. Photons being affected by atoms, nucleuses, electrons. That's what they're interacting with, and that's what's changing their direction. Are those atomic forces that are really big and strong on that size particle. Electrostatic forces, electricity is the strong force, okay, when it comes to the atomic structure.
In the sense of an interference pattern.
Direction of the photon and creating an image on the target. Yeah, I mean each photon.
Right, and if you have one slit, you basically get something that you could call a blurry, out of focus, but nonetheless an image of that slit. And if you shoot BBs through a slit or you shoot light, you'll see this image, this shape, right? The thing is, if you have two of them, the BBs will just have two overlapping, the same shape repeated again for the second one, and they'll overlap. Waves will also show the interference pattern. It's a big difference.
Well, I'm not going to argue this over and over and over again, so that's why we should adjust the slits. So let's have triangular slits, number one, then we don't have to worry about the variable size. So let's just make the slits triangles, two triangles, okay? And that way we'll also know if there's any reversing on the other side, and we'll see what the differential means. How far they'll be further apart and more narrow at the top, and then they'll be right in the middle, will be the part you think is the right amount of distance, and then we'll have wider at the bottom. So we'll have all that variation built right into the slits themselves. That'll save us a lot of trouble, won't it? Let's do this experiment that way and see what we get. Okay, that's for broad starters. Right there, we're way ahead of this game. But I'm still going to argue that as long as you're shooting random gun, you know, it's just shooting, these are missed shots. And what they do, another sneaky trick, you know, people who did this experiment, and I found this out, but I mean, maybe somebody's done it legitimately, but I'm just saying they did do this, which is just bullshit. They start off with one slit right in the middle, and then they had two slits. Yeah, guess what? They put one over here and one over here. So now the middle, where all the stuff was flying before, all the straight shots were going in the middle, now they're only catching the wide shots. So now they're hitting the irregular shot photons. Not the straight ones, they're hitting the ones that are already on a crooked trajectory. So now that doesn't make a whole lot of sense, right? The two slits would be catching the irregulars, not the straight flyers, and the other one's catching the straight flyers. So of course you're going to get a different result. The catch would be to have one slit and have two slits, and just have a door, so you can just take the door up and just take the door down. Door up, door down, door up, door down. And then you can keep the gun exactly the same. You can have two slits, one slit, and it'd still be catching irregulars rather than regulars. Now these are just simple little things that I think you can add to the two-slit experiment to validate these results, but they don't do it. Why? Why? Why don't they do this?
Signifies something.
It's because of its own direction, just like an image form. So you can take.
All right, we'll catch up to this bullshit. But really, that's just bullshit.
BBs through a slit or you shoot light, you'll see this image, this shape, right? The thing is, if you have two of them, the BBs will just have two overlapping, the same shape repeated again for the second one, and they'll overlap. Waves will also show the interference pattern. It's different. Signifies something.
Because of its own direction, just like an image form. So
Yeah, I was wrong on this part.
The pinhole camera is a camera, it's just a pinhole. And, you can take very high-resolution pictures. If you have a very small hole, you'll take very high-resolution pictures just like you had used a lens. And it would be upside down and reversed. Because the light has been bent by the edges of the material.
That's actually...
Yeah, right. That's actually wrong. Yeah, the problem is it also takes time. It's the time lapse. Because I'm trying to figure out the cone idea doesn't really work because there's not enough light intensity, but over time there is. But anyway,
Really not at all true. If it was bending that light, you wouldn't get an image. The reason a pinhole camera works is because the light just comes straight. Only light from one incidence angle can come through, and all the light comes through that little hole. Think about it. The light comes in as a cone and then goes out as a cone. The two cones are the same shape. Because it...
But isn't that part of let's take out the interference part of it and let's just deal with the light part of it. So if you have a little tiny hole, a pinhole, right? Just a little tiny, tiny, tiny hole. Only so much light can get through it. And so which we're arguing about is, so there's a little hole right here, and then we have an image over here, and we're going to have its copy is going to be over here from the light being reflected. So we have a light source that's on something here. The light goes through the little pinhole, only the light that reflects at this precise angle, but this angle changes for everything in the image. So that's still... I don't still understand why it wouldn't get flooded. But anyway, it doesn't really matter. I'll have to think on that one. Okay, but I'll concede that it's not being reflected, it's being filtered. So there's a difference between filter and reflecting. So I guess what I would argue is, or demonstrate that by, okay, here's a gap in my fingers. If I turn that gap at a certain angle, it closes. So there's an opening, and then at a certain angle it closes, and that's what's happening with the pinhole camera. Is it's essentially closing to anything that isn't coming at the right angle to fit through the gap. So if it's at the wrong angle, it won't go through the hole. Essentially.
It's not a lens. It's able
Wow,
to have this
wow.
kind of flat focus thing.
Right.
Well,
Okay. Wrong, I was wrong on that.
The hole is made out. The hole is in. And that's all that's taking place here. There's no phenomenon.
Okay, we'll jump ahead to when we get back to quantum again. He starts this part. I'm arguing about the two slit again. See, two fingers. And he says Einstein even tried to find mathematics. So again, he's going back to the mathematics, and the mathematics isn't what's being argued. What's being argued is the source of the probability wave, and whether that probability wave represents something real or something created, and whether at the impact of the slits, whether that probability, that unknown probability, has anything to all to with what takes place at those slits. And I say it has nothing to do with it, and I say it's a property of the elementary matter, the elementary particles that creates the phenomenon when they interact. Again, photons interacting with electrons and atoms. There are no two slits, theoretically.
So looked at this, and nobody's figured out a mathematics that explains it your way. And you're like, well, they just haven't thought about it. Okay, well, they've had 100 years to think about it, and I just...
Well, once again, your mathematics hasn't claimed anything either. Your mathematics has created a hidden variable, essentially. Quantum mechanics just creates another variable, this probability wave. So what we're just arguing the source of the probability wave.
Agree, they've thought about these things. You say they haven't thought of shooting electron beams at other stuff. Yeah, they've shot electron beams at everything.
Well, I'm saying I've gone through as much as I can go through. I've looked for all these experiments. I find ones where they made them out of whatever, silicone or something, covered with gold plating. I've seen little tiny two-slit experiments and big two-slit experiments, and none of these experiments are good enough.
It does not go on both sides. All that's really taking place is the mechanics, the physics of the interference is consistent because of the consistency of the photons. And so depending on how far away from the slit material the photon is when it passes, it will be deflected in regular proportions. It's a lot like...
But that doesn't explain the dark spots. See, the interference pattern has dark spots, places...
Yeah, see, well, it does explain the dark spots. The dark spots are where it would have gone if it didn't get bent by the right side or the left side. And that's why I'm going to argue again about that's why the outside walls in the two-slit experiment are there, is because they're adding some of those dark spots. But the dark spots are where it's what's left over when you... It's like if I put the single needle in front of it, and I create the deflected light that goes around, well, that light would have gone somewhere else if it didn't go around the needle. And so now where it would have been is where the dark spot is. Get it? So the dark spots are just because the light's been moved to a new location.
Where it's not likely to go, right? And the thing is, it takes this interference to make that dark spot appear where it appears on the screen. And the math that tells you exactly how far apart the lines on the screens and what the pattern will look like is wave mathematics based on the width of the slit, the wavelength of the wave.
Well, exactly. I'm not arguing any of that. Again, you keep going back to math, and we're talking about the theoretical. And there's nothing in what I'm just arguing that wouldn't create the same phenomenon. I mean, it's the same amount of energy going in. You're just saying that the reason why it's doing this thing is because it's a single particle interfering with itself. I'm saying it's a single particle interfering with the slit material, and probabilistically you're going to end up with the same results if you shoot particles this randomly, at least this scatteredly. If you shoot scattered particles in a pattern that is consistent, yeah, you're going to get that pattern on the back wall because of how they're going to interact with those four walls. And it's those four walls that are going to create your 8 slits. I mean, your 8 bars.
Atoms will only create photons when certain energy levels are reached. They have to peak at certain energy levels before a photon can be released. So you could... They're kind of digital rather than analog. You can't put a little bit of energy in and get a little bit of energy out. You have to put enough energy to get to the energy level necessary to pop out a whole thing. You can't pop out a half a photon. And that interference between these small particles becomes very regular and very almost digital.
Didn't need this part, sorry.
It'll be diffracted
See what he
1
says to it,
degree
though.
or 3 degrees.
Almost out of
7
time.
degrees. It won't be diffracted 2 degrees.
Come on, hurry up.
It's
Shut up.
that, probably some kind of effect like that,
Come on, Bureau.
that's creating...
Yeah, that's why if you shoot a light, remember this is done with electrons, and when you shoot the light at the slit, it does fan out a bit. And that's based on the wavelengths, and it could be related to various probabilities you're talking about, quantum probabilities. The point is, when you have two of those patterns overlapping, there's the dark spots where the waves cancel out, and that's the interference.
Well, again,
those should all be light spots. It's in a light.
Yeah, batteries. Anyway, so I don't know where we left off, but yeah, you're saying it's interference. I'm saying it's the necessary wavelength dictating, based on the math of the slits and the interaction, how much the light will be refracted, deflected, diffracted. Whatever.
A spot from one slit and a light spot from another slit ends up a dark spot.
Yeah, well, anyway, we know dark spots are spots where nothing goes, and I'm just saying that nothing goes there because it is either or. It's interfered with by one side of the slit or the other side of the slit, and it is deflected that much of a difference, and that much of a difference in every one of those angular incidences that are possible from the source. The source decides how random it can be. It can only be so much randomness, so it's there's nothing bouncing off exterior walls and then going through the slits, I don't think. So, you know, it really depends on what these sources are. But regardless, the point is there's a percentage of deflection, and I'm saying the deflection is what is all or nothing. It deflects either 10%, 50%, or 90%, like whatever those three would be. And once you do those calculations of 20, 50, 70, let's say, then you could just say that for each incidence, depending on how close it is to the wall, it will be deflected that percentage amount. And so I think there's math to make this fit. I think there is.
What appears to be an interference pattern, which is what
Oh, back to me. This is a good line of his.
Mathematical representation of the fact.
Look, you need to do the math. It's like, why am I even bothering to do this? I haven't gone through this with you in quite a while. And really...
Yeah, well, look, again, this isn't about the math. You keep arguing this is about math. It's not about math, but whatever.
It's tedious. But I'm doing it because people, I think, has a good common sense view. It's like, there's no argument about this as far as I'm concerned. It's quite obvious. You're dealing with science that's over 100 years old. That's what they teach you in school. That's what you believe. That's that.
Right, and all the greatest physicians in the world, you put them in a room and they can't agree on what's taking place. So I'd say that's pretty much fail. When they can't decide whether a cat's alive or dead inside of a fucking box, I think their science is in a little bit of fucking goddamn trouble, and I think they maybe ought to do some goddamn experiments to figure out one way or the other whether the fucking cat is alive or dead. I mean, this is kind of silly. Alright? It's kind of fucking silly. Conversations about photons that are figuring out whether we're watching them or not. I mean, you can't smell how that makes science look like a bunch of shit, and that maybe they ought to figure this out. They've had this stupid experiment for 100 fucking years, and they can't seem to figure out how to do it so they can eliminate the obvious, and the obvious are, don't